Okay, so I am going to go over the homework that you guys had from March 27th. So the first section talks about finding the probability, okay, with or statements. Now, it says identify if the events are exclusive or inclusive, okay? So another word for inclusive is overlapping, okay? So mutually exclusive or overlapping, all right? Now, the first one, it says the probability of 4 or a 5. Now remember, if you're determining between mutually exclusive and overlapping, okay, these are your or statements, you are going to make sure that you follow the formulas that I told you in the PowerPoint, in the video that we talked about on March 27th and March 25th, okay? So you are going to be, so with either mutually exclusive or overlapping, you are going to be adding or subtracting, okay, based on if it's exclusive or overlapping, okay? All right, so the first one, probability 4 or a 5. Now, mutually exclusive means they have nothing in common, okay? Overlapping means that there is going to be some overlap, okay? 4 and 5 are two totally different things. So the first one is mutually exclusive, okay? So when they are mutually exclusive, all you're going to do is you're going to add, okay? So you're going to take the probability of A plus the probability of B, okay? Now, the probability of A is the probability of 4. The probability of B is the probability of 5. Okay, so my first event is 4. My first event is 5. Okay, so let's look at that one a little bit closer. So probability of A. So the probability of getting a 4 is 1 out of 6. Okay, there's only one 4 on dice that has 6 numbers. Okay. You are going to add that to the probability of B. Now, there is only one 5 on the dice, so you're going to do 1 over 6 again. Add them together. This is 2 over 6, which is the same thing as 1/3. So 1/3 is your answer. Okay? Part B. Okay, so you have the probability of 1, 2, or 3. So I'm saying that these two events, there's no overlapping here. So I'm going to say that they are mutually exclusive again. Okay, so that means you're going to take probability of A plus probability of B plus probability of C. A is 1, B is 2, C is 3. Okay, so the probability of getting a 1 is 1 out of 6. The probability of getting a 2 is 1 out of 6. And the probability of getting a 3 is a 1 over 6, which is 3 over 6, which is 1/2. So the probability of you rolling a 1, 2, or 3 out of a 6-sided is 1/2. Okay? All right, let's look at C. The probability of an odd number or a number greater than 4. So odd numbers are 1, 3, 5. Numbers greater than 4 or 5, 6, and that's it, because we're only doing a 6-sided dice. Okay? There is some overlapping, which is the 5 here. So these are not mutually exclusive. This one is going to be your overlapping. Okay? Now, when you are overlapping, you are going to take probability of A plus probability of B, and you're going to subtract the probability of A and B. This is the symbol for and right here. Okay? So when I do that, because I have some overlapping here, I can't count 5 twice. Okay? So the probability of A is that I have an odd number. The probability of B is that my number is greater than 4. So my probability of A, so an odd number, all right, is 1, 3, and 5. So I have 3 out of 6 plus probability of B, so probability of B, which is a number greater than 4, is 5 and 6. So that is 2 out of 6. And now I'm going to subtract my overlapping. So my overlapping was my 5s, which is 1 over 6. So 3 plus 2 is 5, 5 minus 1 is 4, 4 over 6 is equal to 2/3. Okay. All right, D, an odd number or the number 4. Now, odd number is 1, 3, 5. Number 4 is just number 4. There's no overlapping here. Okay. No overlapping. So I'm going to say that these are mutually exclusive. So I'm going to just add my probability of A plus my probability of B. Probability of A is an odd number, B is my number 4. So my odd number, I have 1, 3, and 5. So 3 numbers out of 6 dice plus number 4 is 1 out of 6. So 4 over 6, which is 2/3 again. Okay. E, I have a number greater than 1 or equal to 1. Okay, so a number greater than 1 is the numbers 2, 3, 4, 5, 6. Equal to 1 is just 1. So there's no overlapping here. So I am going to assume that these are mutually exclusive. So I'm going to take probability of A plus probability of B. So probability of A is a number greater than 1. Probability of B is equal to 1. So probability of a number greater than 1 is 2, 3, 4, 5, 6. So 5 numbers out of 6 dice plus equal to 1. There's only one number equal to 1, which is 1 over 6. And that gives you 6 over 6, which is 1. Now remember, probabilities cannot go over 1. If it's equal to 1, that's okay. It cannot go over 1. All right, F. Probability of an even number or a number greater than 2. So my even numbers are 2, 4, 6. Numbers greater than 2 are 3, 4, 5, 6. Now there's some overlapping here. I got a 4 and I got a 6. So this one is going to be an overlapping problem. Okay. So I'm going to take the probability of A plus probability of B, and I'm going to subtract the overlap, which is probability of A and B. Okay? All right, so probability of A is an even number, so I have 3 numbers that are even out of 6, plus numbers greater than 2, there are 4 of them, so 4 over 6, and I'm going to subtract my overlapping. So probability of A and B, so a number that's even and greater than 2, there are 2 numbers, so 2 over 6. Now, if you forgot to do the minus 2 over 6, you should get 7 over 6. 7 over 6 is bigger than 1, so you know you have the wrong answer. Okay? When we get this, we get 7 over 6 minus 2 over 6, which is 5 over 6. And there's your answer. So if you forgot to do this part, you will get 7 over 6. And this is bigger than 1, and that is not correct. Okay? All right. Now, the next problems are going over talking about cards. Okay, so a card is drawn at random from a standard deck of 52 cards. The first thing you need to do is if you need to determine if they're mutually exclusive or inclusive, or we can say overlapping. Then you need to find the probability of A and B. So these are your steps here, step 1 and step 2. Okay, so number 2. We need to determine if they're mutually exclusive or overlapping. Okay, so if a card is a heart or if a card is an 8. Now, if you are familiar with a deck of cards or if you need to go back to another video, you should see that you can have a heart, you can have an 8, and you can have an 8 of hearts. So these are going to be overlapping. So I'm going to do probability of A plus probability of B minus probability of A and B. Okay, my probability of A, so probability of getting a heart, there are 13 hearts in a deck. There are 4 eights in a deck. And there is 1 8 of hearts in a deck. Okay, so when I get these, I get 13 plus 4 is 17. 17 minus 1 is 16. So 16 over 52, which simplifies to 4 over 13. And there's my probability. You could put this into a calculator and get the actual probability, but you know 4 over 13 is less than 1. Okay. All right, number 3. The card is a number less than 5, which is 4, 3, 2. And then the card is a jack, queen, or king. So there is no overlapping here, because here I'm talking about jacks, queens, and kings, and they are not less than 5. So there's no overlapping here. So I'm going to say that these are mutually exclusive. Okay, so I'm going to do the probability of A plus the probability of B. So the probability of A, so the number less than 5, so I have 4, 3, and 2. Now, I have 4 different suits for 4. So 4 can be a spade, it can be a club, it can be a heart, and it can be, oh my gosh, what's the other one? Spade, club, heart, and there's another one. I forget, but there's 4. Okay, so there's 4 for 4, 4 for 3, and 4 for 2. So we're going to do 4 times 3, which is 12 over 52. Okay, plus probability of B. So jack, queen, or king. So again, there's 4 jacks, there's 4 queens, and there's 4 kings because of all the suits. So here we're going to do 16 over 52. Oh, sorry, 12 over 52. Okay, so this is 24 over 52, which can simplify. Let's see. Six over 13. Okay. Oh, diamonds is the other one. There you go. Spades, clubs, hearts, and diamonds. So there's 4 of spades, 4 of clubs, 4 of hearts, 4 of diamonds. 3 of spades, 3 of clubs, 3 of hearts, 3 of diamonds. Okay, so there's 4 of each one. Okay, next one, number 4. All right, the card is red, and the card is ace of spades. Now, spades is black. They are not red. So this is going to be mutually exclusive. So all you're going to do is you're going to add the probability of A plus the probability of B. So red cards in a deck. Okay, so the red suits are hearts and diamonds, and there are 13 of each. Okay, so you're going to say 26 out of 52 cards are red. Probability of B, so the probability that you have an ace of spades, well, there's only 1 ace of spades. So you have 27 out of 52. And there's your answer. Okay, so that is mutually exclusive and overlapping. So that was the front page. So you're either adding or you're adding and subtracting depending on if it's mutually exclusive or overlapping. Okay, now we're going to talk about independent and dependent. Okay, so independent and dependent, when you're picking, you either one affects the other or one doesn't. Now, when you have independent or dependent, either one, you are going to multiply. So overlapping and mutually exclusive, we're adding. Independent, dependent are all multiplying. Okay? So you have a bag that has 9 red marbles and 3 green marbles. For each case below, find the probability of selecting a red marble on the first and a green marble on the second. So what I'm going to do, if you are mutually exclusive or overlapping, you're adding and subtracting. Mutually exclusive and overlapping are or statements. For this table here, I'm going to put that sentence into play. Okay, so it says I have 9 red and I have 3 green. Okay, so I'm going to find the probability of finding, so this is I need to find red on the first draw and I need to find green on the second. Okay, so for the events to be independent, okay, that means it's going to be replaced. So I'm going to find the probability of a red, then a green. Okay, so to find that, I am going to, remember, it's multiplication. So the probability of A times the probability of B. So the probability of me picking a red first is going to be 9 out of 12 times the probability of me picking green second. Now I'm replacing that, so there's still going to be 12 marbles in there. Now I need a green one, so my green one is 3. So this is 27 over 144, and that simplifies to 3 over 16. Okay, now I'm going to write a dependent and find the probability that it is not replaced. So probability of A times probability of B. So it's still multiplying. Find the probability of A, which is finding a red marble. Okay. So I have 9 over 12 times. Now I'm not replacing that marble, so I'm assuming now there's 11 marbles in there. I'm working with 3 green, so I'm keeping 3 over there because my first one I'm assuming was a red one, and I'm assuming a red one is the one I took out. So 27 over 121, and I'm going to leave that because it doesn't simplify. All right, read each scenario below, determine if the events are independent and dependent, then find the probability, okay? So the first one says, a bag contains 5 red marbles and 7 green marbles. You randomly draw, replace, and randomly draw a second marble. So I have my 2 events. I need to say whether they're dependent or independent. Now, because I said replace, that it's telling me it's going to be independent. Okay, the probability of me choosing a red marble is going to be 5 out of 13. The probability of me picking a second red marble after I've replaced it is still 5 out of 13. And I'm going to multiply those. So I should get 25 over 126. And there's my answer. Number 2. An aquarium contains 6 male goldfish, 4 female goldfish. You randomly select a fish from the tank, do not replace, and then select a second fish. What is the probability that both fish are male? So I have my 2 events that are already into the sentence. Okay, I have to choose whether they're independent or dependent. So because I'm not replacing, it is going to be dependent. So my second choice depends on what I choose first. Okay, so probability that my first fish is male is going to be 6 out of 10. Now, probability B, I'm assuming that the first fish was male, and I'm assuming I was correct. So, I'm now choosing from 5 male, and 9 of them are total. Okay, so your second event is based off your first. Your second event is assuming that your first one is correct. So, you're assuming your first one was correct. Okay. And you're going to multiply these. So this should be 30 over 90, which simplifies to 1/3. Okay. The next one, you write each letter of the words, each letter of the word international on a piece of paper and place them in a bag. You randomly draw one letter, replace it. Okay, keyword here is replace, and randomly draw a second letter. So because I'm replacing, it is independent. My first event is taking a letter T. So my total letters in the word independent are 13. Now the first letter is T. I have 1, 2 letter T's. So 2 over 13. Probability of B is N. So I have 1, 2, 3 N's. Okay. Now, because I said replace, my total stays the same for over 13. So I'm going to multiply. So I'm going to get 6 over 126, which simplifies to 1 over 21. That's my probability. All right, last one. Miss Enid has some colored pencils in a drawer. There are 6 blue, 8 green, 2 yellow. Eric randomly takes a pencil from the drawer and keeps it. Linda then randomly takes another pencil from the drawer. What is the probability that Eric takes a green pencil? So my event A is that there's a green pencil. And then my event B is that there's another green pencil. And keyword here was he keeps it. So it means not replacing, okay? So this is dependent. Probability of green and green. So I'm going to take, so when Eric chooses a pencil, it is 8 over 16. I'm going to multiply that to, now I am assuming that Eric takes a pencil and he keeps it. So there are 15 total pencils left. Now I also have to assume that Eric did already pick a green pencil. So there are 7 in there. Okay, and I'm going to multiply those. So I have 56 over 240, and that simplifies to 7 over 30. Okay, so going back to the first, if you are independent or dependent, you are multiplying. Independent and dependent are and statements.